Electricity and water, two forces that rarely mix safely, together create one of the most misunderstood yet fascinating topics in physics. Many people have heard the phrase, "water conducts electricity," but the science behind it is much deeper and far more nuanced. To understand how electricity travels through water, we need to explore how electrical current actually moves and what makes water either a conductor or an insulator. At its core, electricity is the flow of charged particles, usually electrons, through a material. In metals, electrons move freely between atoms, which is why they conduct electricity so well. Pure water, however, is surprisingly a poor conductor of electricity. If you had absolutely pure distilled water, without any dissolved salts, minerals, or impurities, it would barely conduct at all. That's because pure H2O molecules have very few free ions or electrons to carry the current. Each molecule is tightly bound, and there's no pathway for charge flow. But in the real world, pure water almost never exists. The moment water comes into contact with air, it dissolves gases like carbon dioxide and picks up minerals from surfaces it touches. These dissolved substances break apart into ions, charged atoms or molecules, like sodium, chloride, calcium, and others. These ions are what truly allow electricity to move through water. When an electric potential is applied, positive ions drift toward the negative electrode, and negative ions move toward the positive electrode. This ionic conduction is completely different from the way electricity moves through a wire, but the result is the same: current flow. The higher the concentration of dissolved salts and minerals, the better water conducts electricity. That's why seawater, which contains a large number of ions, is an excellent conductor, while distilled water is nearly an insulator. This difference also explains why electric shocks are more likely in a swimming pool or a flooded basement than from pure lab-grade water. Even small impurities like sweat or dust can significantly increase conductivity. Now, when electricity travels through water, it doesn't move in straight lines like it does through a copper wire. Instead, it spreads outward in all directions from the source, much like ripples in a pond. The current density is strongest near the source and rapidly weakens with distance. This means if a live wire falls into a lake or pool, the voltage near the entry point is extremely high, but it drops off sharply as you move away. However, the area around that point can be deadly because the voltage difference between two spots in the water can force current through a person's body, especially between the head and feet, where it can disrupt heart or brain function. This is why electrocution in water is so dangerous and deceptive. You might not need to touch the electrical source directly to be shocked. Even a small household current leaking into water can be fatal because the human body itself is mostly water and conducts electricity well. Muscles and nerves rely on electrical signals to function, and when an external current interferes with those signals, it can cause paralysis or cardiac arrest. That's why swimming near electrical equipment like dock lights, pumps, or boats connected to shore power is extremely risky. In summary, electricity can indeed travel through water, but not because of the water molecules themselves. It's the ions dissolved in water that make this possible. The more impurities or salts the water contains, the more dangerous it becomes as a conductor. Electricity and water together form a potentially deadly combination.